data viewer. So anyway, we hit a period after a dry period in Florida for about a week and a half, actually. We've hit a wet mode again, and that's not that unusual to sort of go back and forth. So, you know, they lead with their discussion here, basically, that storm coverage will remain at or above normal through late week. And then their big picture description they like to talk about is essentially a low pressure system. This is a surface low pressure system, basically, which is sort of gliding up the eastern seaboard of the U.S., which is off of North Carolina, off the Carolinas today, quote unquote, basically. And there is a trough, a surface trough, that's manifest not only in the surface pressure, sea level pressure, but it also shows up nicely as a cyclonic curvature in the wind field. I'll show you guys that also in a few minutes, basically. And, you know, the classic, you know, you wake up in the morning in Florida, right, guys, and what do you think? You wake up early in the morning and what can you say, basically? We bring open the window, so for the gang here. So when you do, you wake up and, Kelly, you really don't see much going on, except if you're in Florida anyway, it's pretty much the same thing. Mid-70s dew points, forecast for 90, hence the joke on the t-shirt says a 50%, you know, chance that I'm a meteorologist, flip a coin, but that's really not fair. So, so one of the subtle changes basically that are not noticeable to us are changes in the precipitable water vapor. And so that's what the Weather Service is talking about this morning. They're talking about deeper moisture spread across the area, essentially greater than 2 inches plus. Now, for my freshmen or the budding meteorologists in the room, you've also heard, you know, you'll see this PW. It's short for precipitable water vapor. I like to call it P-Wat. That's why Zachary Watson, I like to call Z-Watt. And so basically, sorry, I can't help it. Anyway, Emma and gang, what's my point? My point is that actually I'll show you a sounding here, folks, in a little bit. How do you get precipitable water from a sounding? Well, you send up a weather balloon, it measures temperature, and it measures dew point. And that dew point can be essentially translated to a water vapor loading of the atmosphere at a given level. And you just add all that water vapor up basically in the column of the atmosphere. Most of it, 90% of it's below about in the lowest kilometer or two in the atmosphere. There's not much as the air basically cools aloft. There's not much water vapor aloft. Relative humidities can be high, but even at high RHs, not much water vapor aloft. So you most bang for your buck near the lower portion of the sounding, near the surface of the earth. Anyway, we don't really sense much in the way of variation. I've kind of digressed here, but we can have quite a bit of variation basically in the precipitable water vapor this time of year. We get dry air that comes in above the surface, not noticeable by any of us that occupy our lives at the surface in Florida. If we had mountains like Anna had out in Colorado, then we might be able to climb up a couple of thousand feet and notice some vertical gradient in the moisture in the atmosphere. But in Florida, we're kind of stuck. So unless you're a pilot or something, you're kind of out of luck there. But anyway, 2 to 2.3 inches, for those who don't know, is pretty high amount of water in the atmosphere. So again, how do you think about precipitable water vapor? If you take a sounding basically, and you take all the water vapor in the sounding and condensed it basically, that would be the depth of the water basically in that column. So a couple of inches, that's respectable. So if you get any kind of training echoes, basically you can get a lot of water out of these summer thunderstorms with that kind of precipitable water vapor. And when it goes down below 2 inches, generally, repeat, it's not the surface that's basically, you don't notice much change of the dew points at the surface. It's what's going on above the surface, basically, that's reducing that precipitable water vapor. So hopefully that's clear. And so given that amount of water vapor, basically in the column of the atmosphere, and they're referring to the XMR sounding, which went up at a weird time this morning. I'll show you that in a few minutes. They're still going with pretty high above CLIMO precip chances. So we're looking at 60 to 70%. And then they mentioned high resolution model guidance all seem to be in good agreement with a broken band of showers and storms developing across Florida during the pre-dawn hours. So we're going to look at the high res. We're going to actually look at the high resolution and rapid refresh basically. And so I'll look at that forecast coming up. Those models can get you in all sorts of trouble, so you don't want to put too many eggs in the basket of a single model realization. But it does give you some feel for what that one particular model thinks is going to happen today. And then they're talking about this band of convection. Now, those who live in Florida, that, we have people online that are not in Florida at the moment, but those in Florida basically might have noticed a band had come through our East Central Florida yesterday afternoon as well. So I'm not sure the evolution of today's event, how close that's going to be to yesterday's. We ended up not getting much rain at our house whatsoever, less than 1/10 of an inch actually with that band. We had quite a bit of wind out ahead of it along the gust front, but not much water. Anyway, this band of convection will then shift southward into Lake and Volusia counties into the morning. So it's coming in from the north. And we'll take a look at the some data here shortly to confirm that. And then basically continue southward through Orlando to the Cape by late morning. So actually, this is not, Colin and Cassie and gang, this is not a classic sea breeze scenario today. In fact, actually, let's go down and take a look at the next paragraph. So middle of the summer, sea breeze is generally active. And what do you have here? Low-level offshore flow, so westerly flow near the surface, basically, appears to be strong enough to prevent sea breeze formation from most of East Central Florida. So the convection we get today is going to have probably absolutely nothing to do with the sea breeze, go figure, at least in our neck of the woods. And this system that they're talking about, this convective cluster coming in from the north-northwest today, is definitely not of sea breeze origin. So it's a bit of a weird weather day. Because it's more organized than sometimes basic sea breeze convection, it might be a little more forecastable than normal today, but still difficult, right? And so with the exception of being along the coast of Martin, south of us, Martin County, just north of Palm Beach, and potentially St. Lucie counties, it's also, I said northwest, south of us. St. Lucie counties, basically, well, this will limit potential for boundary interaction. So obviously without a sea breeze, you're a sans boundary, but you still obviously have rain, cool air, outflow boundaries that will possibly generate subsequent convection. That's where things get a little difficult, of course. But what are the threats today? Classic, though. Threats for summer thunderstorms in Florida will be frequent lightning strikes, gusty winds, so could get windy, folks, and locally heavily rainfall. So 50-mile-an-hour gusts, respectable. I'm always rooting that on. And then basically they have an earlier start to convection across Lake and Volusia counties, those are north of us. It will likely keep max temperatures limited to the upper 80s near 90 degrees. However, farther south highs will be able to reach low 90s. Remember, if we're on the East Coast, folks, and we have westerly flow and not onshore flow for sea breeze penetration to the East Coast, we tend to be warmer along our coast. Alex, if you're working from home or you're over in USF, clearly the West Coast today probably won't be as active, but you guys will have a sea breeze off a very warm Gulf of Mexico. Anyway, although that might not be noticeable as well with the strong westerly flow, you might not even notice a sea breeze passage either, though, but you will have onshore flow on your coast. Anyway, this goes into the future, so I don't really want to talk any more about that. Into the future, really want to focus on today. So let me back up now. So this trothiness along the East Coast, kind of interesting. And so I haven't showed it to you yet, but if you go to the Hurricane Center, voila, they are actually tracking that surface low. And so if we take a look at their discussion on that one, I can bring that up here. Basically, let me go ahead and click on that. So they're talking about an elongated area of low pressure located along the coast of northeastern South Carolina. The system is producing basically, as you can see here, pretty nice convection. Let me see if I can't get that. It gets kind of tricky, I suppose, and try to keep that alive and talk to you about it. Let me just move it up. Well, I guess that's as good as it's going to get. So anyway, you can see an area bright white basically there off the Carolinas. That's some deep convection just to the northeast of our region basically. It's got a fairly good chance of developing, they say, into either tropical or subtropical cyclone. when I teach weather briefing, clearly I do talk about that phase space that delineates between what we call a tropical cyclone versus a subtropical cyclone. There's been a lot written on these things. One of the key criteria in that sort of parameter space, so to speak, is the warm core feature of a tropical cyclone. So when you go from tropical to extratropical, subtropical is kind of this hybrid in between those two regimes of cyclones, right? So mid-latitude cyclones are also called extratropical cyclones. Hurricanes and tropical depressions, tropical storms are all tropical cyclones. Then you have the subtropical world, which can't make up its mind, right? And so those storms basically are tweeners. So one of the tweener things is this idea of a warm core, which is a characteristic of tropical convection, and distinguishes it from extratropical convection, which is cold core. Okay, cold core just means the temperatures are warmer in the interior of the system and vice versa. All right, so anyway, so they are expecting favorable environmental conditions for the next several days. So they are expecting some development, and the formation chance extended out 120 hours or 5 days is 70%. So kind of cool there. And then, you know, Dr. Earl starts getting excited, basically, I know when you think about death and destruction anyway. And so, you know, you can also see this baby start to come off. So when things start getting interesting off the basically Western African coastline and enters the essentially far Eastern Atlantic in the main development region, the MDR, especially as we move into the peak of the hurricane season. These are the source of the big storms, basically, in this region. So anyway, the Hurricane Center has nothing on that one, but still interesting and might be worth watching. So anyway, I'm going to start showing you guys some weather maps here, and we'll take a look at this feature off the Carolina coast, basically, and we'll call it good. So let me go ahead then. That's all I really wanted to show there. And bring up my IDV. So what do we have going on? These won't be the most current maps, but I don't feel like updating it takes so long. But pretty recent. So a beautiful visible satellite image. And so this one, basically, you can see the timestamp in UTC up here. So right there, it is 1341. So this starts at 9:40, take off 4 hours, right? That's UTC or Zulu time. So if we take off 4 hours, basically, we're looking at 9:41 this morning. Yeah, that's right. So anyway, I guess I could have updated this. And I could step this in motion, and you can actually see it doesn't take much of imagination. Oops, back. Okay, hit stop, back it up. Let's take a look at this kind of nice features. You can actually see some pretty nice stuff in this visible satellite feed here. It looks like the last loop, again, is 10, yeah, this was 10:30. I just didn't update it, sorry. So this is a little old, oops. Back her up here. All right, so what do we got here? So let's highlight a few cool things here. There's the band of convection basically in progress here. Right up and through this region. So there's, you know, early day. This is a forced, not sea breeze event. So we've got stuff firing early today, way before maximum heating, way before any sea breeze collisions develop, basically, or initiation starts. And then you can actually see it doesn't take much of an imagination in here. Up in this region here, Dr. Earl can see lots of fair weather Q showing up, fair weather. Let's just say lots of cumulus developments. All these little speckles in here are showing up very nicely. I can zoom in here and basically control X. What did it do there? That was weird. It should get rid of that. It's not getting rid of my, hold on a second. Well, giving me a fit. All right, hold on a second. Control X. Why is it not getting it? Hold on a second. Let me see here. Well, that's weird. Did it die on me? So Control X should erase all, right? All right. I don't know why it's giving me a hard time. You know, the vagaries of Zoom. Anyway, Being weird. All right, so now it's not even, I think IDV might be thinking about doing its own thing here for a second. Yeah, I can't even get it to take a full screen up. All right, well, whatever. Let's see how much it dies on Dr. L after putting this together. So that's the visible satellite imagery. Let me back it up again. It shows up pretty nicely. And so I don't think it takes all that much of an imagination, actually. You can actually see the generally westerly flow. We could zoom in. It's kind of fun. How much pain can I cause by just zooming into our area? I always love doing this. Is like I like to say, this is why Dr. L's not an on-air meteorologist. It would be a disaster, to say the least. And plus, my albedo is a bit high.
Dr. L, after so many years, you would think after having both me and Ryan in that room at times years ago, you would think you would learn not to overload IDV.
Yeah, well, it's amazing I have any hair left. Okay, so anyway, so you can see the convection is pretty spectacular. So it doesn't take much of an imagination, but it looks like I see a little bit of an overshoot here, really nicely, and sort of very nice texture to these fields. So you can see the bubbling Q along this feature, along this sort of line that they were talking about. What I'd like to do at this point, control, wow, that's really annoying. Okay, get rid of that. So kind of cool. Let me do this. So I want to go to the high resolution rapid refresh, the HER, for a second. Why would I look at the HER? There are a lot of model choices. High resolution helps. So a global model is not really a great place to look for, or to try to look at for convection, especially detailed convection. So the HER is a nice choice. The other nice opportunity to, other nice thing about the HER is not only is the spatial resolution good, but the time resolution as well. So the output's available hourly. So if you go to like a global model, like the global forecast system, it's usually every 3 hours, not every hour. And they cycle the NCEP, the National Centers for Environmental Prediction, actually cycles the HER every hour on the hour and runs it out about 18 hours. So it's always updating, continuously bringing data in and running, and not waiting on a 6-hour cycle, but on a 1-hour cycle. And so for the latest and greatest, you live and die by the sword, as they say. I like the HER, but you do have to be careful. And like I said, convective forecast can be humbling. So one thing you guys can do as a sanity check on a forecast day is you can actually just see how well the HER matches basically current conditions. Because if it doesn't have what's going on now in the atmosphere, you kind of SOL there, right? It's not a good sign. And so I'll do that as well. So I have a composite reflectivity. So this is actually model reflectivity. This is not radar. No radars were harmed in making of this reflectivity pattern. This actually is from model output, okay? It's from the HER. And so I need to step it forward. Let me pull that off because the HER won't start. There we go. So, so this is the earliest. This was this morning's HER, not the latest HER forecast cycle. So pop that in. So this is what they have basically at 1436, 14. So right around the time, let's bring it to 15Z. So this is the HER, and I guess it marches forward from here. There you go. These are hourly. So this is basically valid at 15 UTC, maybe 14. Let's just go at 15. I think it's 15. Yeah, it's 15 UTC, which would be 11 a.m. this morning. Okay. And so I'm just going to dance back and forth. Visible. Not bad. Right. So this is a repeat. Repeat. This is a, not so good, right? This is a forecast from this one of the cycles earlier this morning. I forget which HER cycle. It's a few hours old. So it is picking up, Jason and gang. It is picking up, basically, Emma. It is picking up Z-Watt, some of the convection, basically, that's ongoing now. So that's somewhat reassuring to Dr. L that the model's not out to lunch, basically. So again, let me back. Not bad. So it's got this cluster in here showing up pretty nicely. Not bad. This cluster existed already this morning.
Just
Just because you put it in the model doesn't mean it's going to stay in the model. it's like Vegas, right? What happens in Vegas doesn't always stay in Vegas, and what you put in the model to initialize it doesn't always stay with the model. And so these are problems with convective, especially with convective forecasts. So anyway, Santino and Emma and Cawthor. Hi, Cawthor, by the way. I don't see you, but hello. It's good to see you on with us. Anyway, so bring this back up here for a second. All right, so that's kind of cool. So let me get rid of the visible image then and back off and see what the model does then with this cluster that's to our northwest. And so Z-Watt and Josie and rest of the gang, basically. Here goes Dr. L. Let's put this in motion. So this is 11 a.m. And again, the her is hourly, right, Colin? So let's step it forward. And then I guess what these are, all right, so there we go. So it looks like that this is what the Weather Service is going with this morning. So you can actually see this cluster moving south and east through heading towards Brevard County out of central Florida. So this is definitely not sea breeze convection propagating south and east. And if you believe this, right, it's got kind of an intense cell here forecast. You know, I wouldn't trust that. But anyway, it does have the line of storms coming in from the northwest, and it looks like an early show with this first line because it looks like this is at 18 UTC, right? So you take 4 hours off, that's 14, right? That's 2 o'clock local time, correct? And so basically it looks like Jason and gang, this could be an early show. As far as that first wave of convection. I forget what time that stuff came through yesterday. It was relatively early as well, but I don't think it was this early. So this is 2 o'clock, right? This is basically 19 minus 15, right? This is 3 o'clock, right? So that wave goes through. So somewhere between 2 and 3 looks like the first push of convection, but according to the HER, we're not done yet. So I have this loop going into around 8 p.m. So this is 4 o'clock, 5 o'clock, 6 o'clock. So it is very possible we could get a second round of convection behind this first wave. If you believe the HER, I put the qualifier on there. So the HER is going with 2 rounds, this early round. Now, how well it handles the overturning and stabilization of the atmosphere as a result of the first set of convection, right? So the idea of convection basically is it releases a lot of instability in the atmosphere, so that has to recover. What could screw up your forecast? Well, you could screw up, what if there's a trailing anvil, right? An anvil or overcast behind the first system that blocks off some of the insulation, the solar radiation that comes into the surface, right? Well, then you're not going to warm as much behind this system. The model might not handle the residual cloud field behind the system as it comes through. So you'd really want to look at more than when Dr. L is looking at then to get an idea really on how well we think things are going to be forecast. You can look at real-time data, right? So if we went back to the satellite data, we could see if there's a trailing, or radar data to see if there's an extensive trailing, basically stratiform rain region behind this system that propagates through. This trailing rain region, basically, or cloud region, could block out some sunlight, right? So that is a major player in generating subsequent convection, basically. And the feedbacks are difficult to forecast, right? And what I mean by feedbacks, I mean something that's not the initial convection, basically, but what comes after the initial convection. It's hard enough to get initiation correct, but the feedbacks, I would say, are an order of magnitude even more difficult. And by feedbacks, could be radiative feedbacks, could be feedbacks related to basically other things, essentially boundary interactions, which get really complicated, sea breeze, outflows. It gets to be really messy really quickly. So these are all tough forecast problems, and they remain so. Okay. Dr. Windsor always says, Dr. L, you really need to breathe. So there's my one breath. And now I'm going to go down for more here. Under I go. So Anna Ham and rest of the gang, and Emma, and let's see what else we have going for us here.